Hello and welcome back to Ganesh Institute. In today's video, we're going to talk about graph theory. So first up, what do we mean by graph? So see, whenever we are having any sort of structure which does not have loops and parallel edges, okay, then we can call it as graph. Now, what do we mean by parallel edges? For example, see, this is a vertex. When I am having two vertices, there is an edge which is connecting these two vertices, okay? If V1 is starting from V1 and ends at V1, then it is forming a loop, okay? V2 is forming a loop. So we cannot consider it as a graph because graph should not have loops as far as the basic standard is concerned, okay? And then what is the concept of parallel edges? For example, this is again an edge. V1, V2 are vertices. If a line is passing through, another edge is connecting V1 and V2. This edge is parallel to E1. Now you might be wondering that parallel is something which do not meet, but here we call it as parallel edges, okay? So now parallel edges basically have same endpoints, okay? V1, V2. For edge E2, we have endpoints as V1, V2. For edge E1, we have endpoints as V1, V2. Because vertices are same, like they are having same endpoints. That's why we are considering them as parallel edges, okay? Parallel edges have same endpoints. All right. Now, what do you mean by order of a graph? Basically, order of a graph is nothing but number of edges. What is it? Sorry, number of vertices. And when we say size of the graph, so the size is defined as number of edges. So for example, if I have created a graph for you, this is V1, this is V2, V3. There are how many vertices? 3 vertices. So order of this graph is 3. And how many, what is the size of this graph? How many edges are there? E1, E2, right? So there are 2 edges, so size of this graph is 2. Then we have another terminology which is clique. What do we mean by clique? It is basically pairwise adjacent vertices. It is a set of pairwise adjacent vertices. Okay, so adjacent vertices means there is an edge between every pair of vertices. For example, let's say if I'm creating this one, V1, V2, V3, V4. This is edge 1, edge 2, edge 3. So when we say adjacent vertices, so V2 is adjacent for this edge and this edge, right? V2 is adjacent for E2 and even because this is common in both of these edges. So if we can have pairwise adjacent vertices, then we will consider it as clique. Okay. Now, what do you mean by independent set? Independent set means it is opposite of clique. That means this is a set of pairwise non-adjacent vertices. Pairwise non-adjacent vertices. For example, in the same graph, this one, if you see V2 and V4, these two, V2 and V4 do not have any edge in between them. So these are non-adjacent and hence we will put them in the set of, we'll call the set as an independent set. Okay. Then how many types of graph are there? There are many graphs. For example, you can say one is trivial graph, another one is null graph. So let's see. When we say trivial, trivial means not important. So here we have one vertex. The graph has one vertex and no edge at all. So it is something like this one. This is vertex and there is no edge. So this, what sort of graph is it, right? So we are calling it as trivial graph. Now when we say null edges, null graph, that is having null edges. Null graph is having no edge. There may be a set of vertices, but there are no edges. They are not connected. This is null graph. Then we have complete graph. Complete graph means if you are having certain vertices, then there must be an edge in between every pair of vertices. There should be no vertices which is not connected with another one. Okay, every single vertex, if it is connected with other one, so it is forming clique, right? Connected one, adjacent one. So we'll consider it as complete graph. Okay. Now if someone says, how can you say, if let's say there are n vertices in a graph, n vertices, it has 4 vertices, order is 4. If there are n vertices, then how, almost, at most, how many edges can be there? At most number of edges a graph of n vertices can have. Can anybody tell me? It is nc2, or we can write it as n2 edges. Okay. You know how to solve combination formula? N factorial upon 2 factorial n minus 2 factorial. Okay. So you know why we are putting here 2? Because an edge is formed by 2 vertices. So there are n vertices. So combination can be nc2, right? So total number of, maximum number of edges can be this much. Now you might be wondering why at most, why not total number? Because sometimes we may have null graph. So in null graph, we don't have any edges, right? Any edge. So in this way, the at most number of edges can be nc2. Okay. And how many vertices can be there? So if we have to find out total number of labeled graph, we are having labeled graph. It is some weights, some values are given to it. So total number of n vertices labeled graph. I should write it n vertex. See what I want to say here. I have a label graph. V1, V2, everything is labeled E1, E2. How many such graph can we have if there are n vertices? It is 2 raised to power nc2. Okay. So let's say I have 3 vertices. Okay. Which sort of graph is it at the moment? Null graph. From these 3 vertices, V1, V2, V3, this is a label graph. From these 3 vertices, how many labeled graphs can I have? What is the combination? How many number of graphs can I make out of these 3 vertices? So one can be a null graph. This is an option. Then maybe I can have only one edge in between V1 and V2. V3 is not connected. Then maybe V1, V2, V3, we have only V2, V3 connected. So this is one possibility, another possibility, third possibility. How many possibilities are there from 3 vertices? So formalize this. Use this formula. So 2 raised to power NC2. What is NC2? N is number of vertices, 3C2. So if you solve 3C2, what is it? 3 factorial upon 2 factorial, 3 minus 2 factorial. That is 3 into 2 factorial by 2 factorial into 1 factorial. Correct? So this is cancelled 3. So the formula is 2 raised to power NC2. So NC2 is 3 here. So 2 raised to power 3, that is 8. 8 possibilities are there. Let's check this out. So this is one possibility. Second, third one. We have to create 8 graphs out of these 3. So what can be other possibility if you can tell me? Okay. I have connected V2, V3. I have connected V1, V2. Maybe another one is I can connect V1, V3. So 4 possibilities. Then maybe I can have 2 edges. V1, V2, V3. E1, E2. 2 edges. Then I can have these 2 connected. Right? Maybe I can have a complete graph where every vertex is connected with other one. V1, V2, V3. You can see V1 is adjacent to this vertex, this edge, this edge. V3 is adjacent to this one. So these 2 are adjacent edges. Correct? Are you getting my point? So how many are there? See. 1, 2, 3, 4, 5, 6, 7, 8. No, this is not the one. So 1, 2, 3, 4, 5, 6, 7. Is there any other possibility which is left? We have got this one. All right, this one is left. Just bear with me. Which one is left? When we have connected these two, one possibility can be this one as well, correct? So this is how 8 possibility, because formula is 2NC2, 2 raised to power NC2, right? In our next video, we'll talk about some of other graphs like bipartite graph. So stay tuned. Till my next video, take care of yourself. Bye-bye.